Okay, in this video I want to talk about types of fossils, casts and mould, and famous fossil sites around the world. Okay, so types of fossils. Now there are many types of fossils due to the different ways in which they can form. Okay, and the type of organism being fossilized as well affects what fossil will eventually be like, what the fossil will be like. And so they're classified via the following. So you have original types of fossils, replacement fossils, carbon film fossils, and indirect fossils. Okay, these are the four different fossil types. Let me begin with original fossils. Okay, these basically form when part of the organism is preserved. Okay, with almost the same chemical composition as when it was alive. Okay, here's an example: complete skeleton of a critter, of an organism. Could be an insect, could be anything. Another example is sea creatures. Okay, that had hard shells, for example. With hard shells, okay, the hard shells make it easier to preserve. Examples are mussels and clams. So they're original fossils. Replacement fossils, so original, you can think of original as being the same as the one that, the original thing, okay, the original critter. What's a replacement fossil? Okay, forms when part of the organism is chemically changed into another mineral. Okay, and it takes a long time to happen, basically. An example is when the calcium carbonate in shells and bony skeletons are replaced by another mineral. Okay, an example is silica. Silica is basically silicon dioxide. Okay, it's the main constituent in sand. Okay, here's an example: the Plesiosaur Backbone. Okay, the backbone of a plesiosaur. Plesiosaur is a sea creature. It's a reptile. Okay, it slowly gets replaced. The backbone slowly gets replaced by silica. Okay, and eventually that gets turned into opal. Interestingly, so that's the replacement fossil. Let me now talk about carbon film fossils. Carbon film fossils, okay. It occurs when a dead body partially decays and leaves behind a thin black deposit of carbon. And I should have also mentioned before, replacement fossil, just think of replacing the actual fossil, right, with a chemical. Carbon film, think of carbon, right? So the dead body eventually forms into carbon. Carbon's that black stuff. So coal's made out of carbon. And when you burn stuff on a barbecue and you get a thin black thing on the outside of the meat, say, that's carbon. Examples are plant fossils. Okay, they're commonly carbon film fossils. Okay, and coal is actually formed in this process by plants decaying, believe it or not. That's carbon film fossils. Now I want to talk about indirect fossils. Okay, it's actually not part of the organism itself. Okay, but instead preserved remains of things such as imprints, okay, of a body. Okay, examples include footprints and tracks. Okay, so it's not actually part of the organism. So indirect, okay, footprints, when you see bear tracks, for example, that's an example of an indirect fossil. Okay, it was planted into the ground, basically, a print in the ground. Examples are bears, crabs, dinosaurs, and so on and so forth. Okay, very different types of fossils. Let me now talk about casts and molds. Casts and molds. If you've heard of these, mold is usually an imprint left in a rock, okay, showing the outside of an organism. So mold equals imprint left inside a rock, showing outside of organism. Okay, examples: an insect or a spider. Okay, there's no actual body left behind, right? It's just the shape of it. Now, as I mentioned, here's how it actually happens. So let's consider a shell, for example, a shellfish or something. The shell is first covered. Here's how it actually happens. First covered in the sediment, okay, some rock and some other material. That turns it into rock, okay. And then the original shell of, say, the crab, original shell is then dissolved by acids, okay, or other chemicals, leaving behind an imprint behind. Okay, an analogy is chemical weathering. Okay, chemical weathering is a process where through which acid rain, so rain containing carbon dioxide, hits the earth, hits calcium carbonate, things like rocks, and you get calcium bicarbonate, and little holes are left in the rock. Okay, that's an example of well, that's similar to what a mold is, right? So the holes in the rock represent the raindrops. Okay. So let me just move on now. As I mentioned, examples: crabs and lobsters. Now that's molds. What's a cast? So they basically form. Casts form when an organism in rock decomposes and space in the rock fills up with soil and turns to rock. As the organism decomposes, it basically tears apart, and then the space in the rock fills up with soil, and eventually you get a rock. And so it leaves behind. So leaves behind a copy of the outside of the organism. Okay, in a solid piece of rock. And an example is a 3D three-dimensional cast of what an organism looks like. Okay, an example is a spider trapped in a rock. Okay. Now, why are fossil records incomplete? Okay, so fossil records are incomplete due to the nature of the organism. Okay, if it's small, if it had no hard parts, then getting a fossil is really hard. Okay, and there's a low chance of it being fossilized after death. Okay, it could be also eaten by something else. It could be in the wrong place. So fossil records are therefore more complete for some organisms than others. Okay. It's got a greater chance of getting fossilized if it lives in water. Okay, so lives in water equals better chance of being fossilized. Okay, and also if it had hard body parts. Okay, an example would be marine organisms. So creatures that live in the ocean have a higher chance. Okay, example is coral. Okay, so they're fossil records. Let me now talk about some famous fossil sites around the world. So okay, here are some two famous ones. Ediacara in Flinders Ranges in South Australia. Another one is Burgess Shale in Canada. And these are both particularly important because together they both provide two consecutive they provide a lot of information on different eras throughout history where critters formed, okay, and when they lived. So let me talk about the Burgess Shale in Canada. It's very simple. So over here there were very simple organisms like sea creatures. Okay, and examples include that of Picaya, can't even pronounce it. And these are like little tadpoles things. They look a bit like tadpoles, okay? As for the Ediacaria, in the Ediacaria site in Flinders Ranges, an era in geological history was named after it actually. Called the Ediacarian era. It was named after it, okay? And flat fossils, so flatworm fossils actually. Flatworm fossils are abundant there. Okay, they're famous fossil sites and they help geologists establish what type of creatures lived at what time throughout history, okay? And this is actually the Ediacarian period was actually the first new geological period to be named in 120 years, in the past 120 years. The first ever period to spring from the southern hemisphere, right? It was actually the Australian geologist. There was an Australian geologist who discovered the oldest multicellular organisms actually in this region. So, geologist named Reg Sprigg, they discovered in 1946 the oldest group of multicellular. Multicellular means contains a lot of cells, okay? Examples include us humans and other animals. Okay, so that's why it's a significant site in South Australia. The oldest group of multicellular organisms are believed to live there.